And yeah, thank you for inviting me to this symposium. And, I noticed the term autographic landscapes in your description, and so I kind of latched onto that, which, I think autography for me is a kind of interesting relationship with the indicator or with the proxy, which I'm going to talk a little bit about. So autography, of course, in this context means self-writing or self-inscription, at least for me. This is just like a small video that I took last week from an exhibition that my students made, where they, put up these telltales that you put on the sails to tell you where the wind is coming from. And in this case, it kind of shows how the traffic and, whatever is going on the street is kind of causing the air to move. But then you also see these kind of circles where the dust of the street then inscribes itself through the telltales. So all of these, in my understanding, are autographic phenomena, not just the more permanent inscription, but also the more ephemeral effects of the wind on the yarn and that kind of stuff. So autography is a kind of a very old-fashioned word. I guess, if we believe Google Ngram had its heyday in the late 19th century, I'm not sure if this is correct, but it definitely was a very important epistemic category, and Emerson captured this, I think, very well in his portrait of Johann Wolfgang von Goethe, when he writes, nature will be reported, all things are engaged in writing the history, the planet, the pebble goes attended by its shadow, the rolling rock leaves its scratches on the mountain, the river its channel in the soil, the animal its bones in the stratum. So he goes on to list different autographic phenomena until he comes to this point where he calls memories also inscriptions in the body. And this is, of course, this may remind us of how also neuroscience talks about memory traces, but I think it also shows the importance of the trace as a very universal epistemic category, definitely in the late 19th century. So, over the past years, I examined this connection between these various forms of self-inscription and contemporary data visualization practices. So I'm coming from data visualization, I'm not a landscape architect. This book that came out 1.5 years ago started as a critique of the visualization field, which I think is still stuck in a very symbolic representational paradigm. And I'm gonna briefly sketch out what I mean by autographic visualization. And yeah, this connects to examples that Susanne talked about yesterday. This is the Großglockner, the largest, the Pasterze is the largest glacier in the Eastern Alps. It's a very popular tourist destination, and you can drive your car to the top and then take this cable car down to the ice in the 1960s when this was built. So you could directly step from the cable car onto the surface of the glacier. You already know what is coming now. If you step from the cable car today, you find yourself in the middle of the mountainside, but you see this little sign that tells you that this is where the glacier was in 1960. So there is now this pathway going down, and it leads to another sign, 1965, 1970, 1990. At this point, getting a little bit tired because it's very high up and it's very hot. Here is the last sign, 2005. But if you see these kind of tiny human figures in the middle, it's still very far away from this lake, which only appeared about like 10 years ago. So a few observations. When we look at it from the perspective of data visualization, the date on the signs is not the visualization. Obviously, the visualization is the mountain or the missing glacier. There is also a kind of a visceralization going on, which is my physical exhaustion level, as the path is getting longer and longer every year, which it actually does. But I think the date on the signs do play a very important role, not as content, but they are the frame. They are framing the way how I look at the glacier. And something interesting happens here, because like, okay, if I go back, I start looking for, these kind of traces. I may notice this line here where, similar to an empty reservoir, the ice may have ended. I'm wondering if this is the line that is left by the ice. So my perception of the mountain is somewhat influenced by these symbolic inscriptions, by these signs. Which of course raises the question, what would happen if someone now would started moving these signs and like putting different dates on them? How would that change my perception? I mean, of course, like we cannot really talk about objective causal experience or anything here, because like it's kind of framed by this design intervention. But to the point of proxy landscapes, I want to avoid a kind of a premature takeaway to say, yeah, this is how we can visualize climate change. Because first of all, something like the climate doesn't exist. It's not a physical phenomenon, it's a statistical concept. The history of the weather, as Paul Edwards calls it. But the landscape does have equivalencies to this statistical concept. The same way how a statistical model integrates data points over time, here, and as we heard yesterday, the ice on the glacier integrates years and years of snowfall and transforms them. So in the context of autographic design, I'm less interested in the landscape as being a kind of an illustration of an abstract concept, but more how this phenomenon offers a different perspective on data, on models, and on computation. And what is commonly described as climate proxies, as stand-ins for measurements, from this perspective are actually autographic data sets, or maybe even visualizations in their own right. So they are not just references, but they are part of the phenomenon. And by phenomenon, I don't mean like nature, but take it also in this kind of Baradian sense that it includes the observer, the researcher. And you see it all of these images, you always see the annotations, different kinds of annotations. So reminds us that those are highly technically mediated, as Susanne said yesterday. I really like this image of the ice core that had these little marks that showed how it was kind of scanned. So in order to get tree rings, you have to cut into a tree. We can also talk about living beings as data or as forms of compute or as media of agents of computation. That sounds a little bit weird, but yeah, I mean, these experiments with plant indicators by the US governments were also an important inspiration. I did a project with ozone indicator plants of tobacco seeds, where they have a kind of a pair of tobacco plants. One of them is very sensitive to ozone, another one is very resilient, and so you can compare to measure ozone episodes. So one of the starting points for the book was the observation that amateur groups, environmental activists, after they have learned everything about data and visualization, often go back to very analog ways of presenting their case. This is an example that started with transportation activists in New York. After a snowstorm, they go out and document the vehicle traces in the snow and mark the areas that are left untouched by vehicles, which they argue could be reclaimed for pedestrians. So one of the guiding questions for this book was, what can these kind of primitive forms of visualization do that data visualization cannot do? If we always hear that data visualizations are so like scientific and objective and so convincing. In this case, they are not really, because it has something to do with the skepticism towards community-generated data. These groups are in some ways always at a disadvantage compared to institutions who collect the data in a more formal manner. So they use often traces to flip the script. Instead of basically trying to emulate the gold standards of data collection, they kind of present these traces and then, ask the institutional experts to explain these. So I looked at many similar case studies of groups and kind of sketched a kind of a design theory that focuses on different moves here of design operations. They start with framing, transforming, you tune traces, you kind of intensify them, or on the other hand, separate them out. If you have a phenomenon that has not a visual, that cannot be visually observed, you generate traces by coupling it with a tracer substance, or by having some kind of registration mechanism that generates a more permanent trace. And at the end, you often find ways to kind of quantify them, or to annotate them, to turn them into data. So we see a kind of a very loose, and it's not always this sequence, we see a very loose progression from a kind of a more phenomenon to kind of symbolic data. And this is basically the idea here, that this is not about creating an alternative to data visualization, but actually visualizing the data collection process itself, so to make data collection more accountable. And yeah, I mean, this is, makes a lot of sense, because data visualization actually, this is the one thing that data visualization cannot really do very well. You can interpret data with different visualization techniques, but it will never show you the origin of data. So now to talk a little bit about indicators. A few notes why I use the term autographic instead of using more common categories of person indexicality, for example. And this is where I started from many years ago, where I talked about indexical visualization. But the difference here is that the index is always a reference, like smoke indicates fire, the red spots on the forehead indicate measles, and so on. And when we start teaching these in textbooks, we, come very close to semiotic conventions again. But as I use the autographic mode, it does not necessarily imply a reference. The trace does not represent anything, it just presents itself. So how I understand kind of autographic design is kind of a non-representational approach to data and visualization. So it doesn't necessarily indicate the phenomenon, but is a part of it. Of course, eventually we will get to the meaning of the trace, but what all accounts of trace reading that I examined have in common is that they try to resist this step as long as possible, to assign meaning to a trace, and rather really figuring first out all the different patterns and connections without really committing to a particular reading. And methodologically, I was influenced by this kind of work on unobtrusive methods in the 60s and 70s that mainly focused on trace interpretation in the social sciences. And Eugene Webb and Wake completely inverted the scientific template here. So for example, their notion of inquiry is not about testing a single hypothesis in a controlled experimental environment, but generating as many hypotheses as possible and then sorting through them through triangulation in a very kind of playful and speculative approach, figuring out like what could have caused a trace. There's always a kind of a story, a narrative element to it when we talk about traces, that we're figuring like what could have happened here. You figure out where these hypotheses align, where they're in conflict, and also use errors and noise as sources of information. And I wanted to note, we can also use autographic approaches to digital data, my recent work deals a lot with kind of non-representational approaches to data, especially synthetic data, which is used to train AI models, which are kind of data sets that just mimic real observations but have no representational reference to anything in the world. So I find that very interesting, because it inverts a lot of this idea of chain of custody that defines whether data, the data quality. Here we have the opposite, because we look at the whether the model that has been trained with this artificial data sets is able to recognize something that I wanted to recognize. So the performance of the model defines the data quality, not the representational relationship with whatever it's supposed to be referring to in the world. So as an example of these kind of non-representational parts in digital data sets, this is, again, very, very simple. This is a data set that you can download from New York City website. It's all the kind of drop-offs and pickups of taxi cabs. It's often used in this kind of big data competitions and hackathons. And you immediately may notice, there are these kind of blurred areas in Midtown, and you may guess that this is because of the tall buildings there. They interfere with the GPS signal, so you have a larger GPS error there. So it looks like a cloud if you have a lot of data points. So I think this is very interesting, because we have just two variables, but now in this noise and this error, we have a third hidden variable, which is the three-dimensional shape of the city. But we can only use this information if we approach the data from a material perspective. If we understand the materiality of how GPS works, that it kind of doesn't go through buildings, and if we have many observations, we can work with this. But this is not necessarily how you would do it in a very traditional data analytic approach, where you kind of exclude the outliers, you exclude those data points that seem a little bit problematic. So this is just like very basic level. There are many more phenomena of autographic inscriptions in digital data sets. But just for the sake of time, I want to just go to some of the things that my PhD students are working on in loosely related to these thoughts. So this is work by Chucho Ocampo Aguilar. He's working with geoscientists in Querétaro in Mexico to uncover a kind of a 400-year-old water infrastructure, the acequia, which was a kind of a early colonial water infrastructure that was initially kind of, commonly governed, but then became polluted and hidden and disappeared from memory. But it had a kind of a interesting resonance and echo in the public imagination, because people still talk about, there are these tunnels underneath the city, and the priests have been hiding there in some historical events. So the same way how the infrastructure is buried and only visible through some cracks in the pavement, the public memory also has this kind of buried ideas that come out when the geoscientists take their cart, the ground-penetrating radar cart, and move it through the city. And then people, they move very slowly, so people start engaging with them and asking, like, what are you guys doing? And, oh yeah, no, there was this kind of thing that we discovered in our yard a couple of years ago. So Chucho is looking at how this kind of performative practice of field work can be used as kind of an interface with the public between these kind of geological modes of measurement and this kind of, more social perspectives. Another PhD student, Sebastian, is also examining phenomena that are underneath the surface, in this case, urban rivers. So he's building a sensor network for measuring underwater soundscapes. There has been some interest in underwater soundscapes recently, but rarely in the context of cities and urban infrastructure. So there's a lot of exploratory work to do. Like really, how does infrastructure sound propagate into the underwater soundscape? How does it relate to the materials of the on the underwater, on the bed of the river? How does it relate to living organisms? How does it relate to the temperature? There's a very clear, measurable connection between the speed of sound over water and underwater as well, and the temperature, which kind of changes the auditory phenomena. So he's looking into these kind of questions from a urban infrastructure perspective. Finally, Paula has been working on borders and language for a long time in Europe, looking also at kind of complaint mechanisms that Frontex offers, like when you complain against treatment by the border agents and so on. So she's looking at the Mexican-American border at Tijuana, the busiest border in the Western Hemisphere. And so her work looks at the border as a socio-technical system that extends far into the territory and the role of administrative language. So she also works with field recordings with kind of in-ear microphones simultaneously from various locations on both sides of the border, and then kind of builds up these kind of simulations where you can hear it and, try to interpret it without all of these, infrastructure in view. Finally, I want to talk about, this is going on right now. My book also talks extensively about analog computation, and I'm concluding with what we're currently working on for the Venice Biennial, for the Architecture Biennale. So we're looking at this kind of computational paradigm of physical reservoir computing that uses the memory of physical media to transform information to make it, distinguishable. So it's an interesting experimental paradigm that is neither analog nor digital. It doesn't really have analogs. It kind of more looks at the it looks at basically just the physical properties of the medium itself. For example, if someone throws pebbles into the canal, the chaotic wave patterns propagate through the city, and they help you learn, where those were thrown in. But you can imagine this principle also with sound. If you imagine a kind of a tone that is slowly changing in pitch, but it's too slow or too small that you can recognize it with your ear. If you imagine you are in a room that is a very echoey room that has a lot of like concrete surfaces and creates a lot of interferences, so then you start noticing these changes because you suddenly have all these interference patterns that are changing the signal. So this is the basis of this seemingly paradoxical idea that by adding a lot of noise into the signal, suddenly you get more information out of it, or you can kind of decode it. And so, yeah, we are currently building this kind of model of this reservoir computing, thinking about like, okay, what if Venice and the water surfaces and all these kind of other different phenomena could be looked at this kind of computational medium from that perspective. So I'm gonna end it here and looking forward to the discussion later. Thank you.
No audio. Or video there is, but it's only just a gift. Okay, hi everyone. Thank you so much for this wonderful invitation. Thank you, Robert. Thank you, Erin, Ray, and everyone that was involved in any capacity in preparing this symposium. It's kind of amazing. It's the first time I'm speaking at the University of Pennsylvania. It's actually only my second visit to the US. I'm very happy I made it through the border, since we were just talking about borders before. And also thank you to all the speakers who presented so far, as well as to Susan for her really timely keynote yesterday, which actually prompted me to wake up at 6 a.m. and rewrite this presentation. I'm a philosopher by training. My name is Lukáš. I specialize especially in philosophy of emerging technologies, ecology, and astronomy. So I kind of oscillate between, I would say, like planetary and extraplanetary context quite often. So currently I'm affiliated with Berggren Institute's Antikythera program, and I'm also an affiliate researcher at Center for AI and Culture at NYU Shanghai, where I also arrived now, and where I recently finished my postdoctoral appointment. So I spent most of my time actually in the province that Bobby, on one of the maps, was mentioned as Hunan, but it's Kentucky, obviously. In fact, I'm born also in Colorado, obviously, in former Czechoslovakia, based on that map. So yeah, it's a real pleasure to talk about the research project that I'm kind of like trying to put together, and this symposium is really a great accelerator for that. A project that perhaps going to be a book project down the line, and it results from my long-standing interest in astronomical sensing and modeling. So tentatively, it is called Architectures and Arts of Astronomical Sensibility, although I do not think that it should be the final title. And its main goal is kind of to frame astronomy as a portfolio of epistemic practices that are transferable across different domains of knowledge making. So in my opinion, astronomy cultivates sensibility towards different modes of mediation. These are intrinsic to cosmic landscapes. It can be galaxies, it can be planets, stars, solar systems, black holes, nebulae. So when I talk about landscapes here, I'm kind of bending or curving or perhaps even lensing the meaning of the term landscape. But today I will, I'm afraid, massively underdeliver on the architectural part of this kind of like a philosophical thinking, and because that will be the part that kind of investigates the technical infrastructural background of the astronomical observation. But if I were to make at least one important side note on the relation between astronomical image and infrastructure, it would be this one. When we look at an image like this one, we are looking at an artifact that is both a refraction and a reflection. And this observation is inspired by actual categories of astronomical technology. We have two kinds of telescopes, refractors that use lenses to bend light, and we have reflectors that use mirrors to reflect the light. So these are two related geometrical operations here, refraction and reflection. Images like these are refractions in the sense of giving an intelligible rendering of a landscape that would be otherwise imperceptible to us. They bend, they break, they magnify, they foreground something distant and unknown. And at the same time, images like these are reflections because they carry an imprint of an infrastructure that generates them. And this is very visible in case of pictures produced by space telescopes such as JWST, since they encode the hexagonal shape of the mirrors of this apparatus. And you can see these 6 arms of light beaming from the stars on the picture. Therefore, the first optical takeaway of astronomy is to me that to study an image as an artifact requires a sensitivity not just to what image represents, but also to the indexical traces of the representing apparatus. And so I imagine astronomy in this lecture as a kind of aesthetic educational tool as well. And while doing so, I deliberately transport the notion of aesthetics back to the 19th century, which means denoting an art of perception, of sensing at large, not just a theory of beauty or theory of perception of artistic forms. And there is a hidden agenda behind this framing of astronomy as an aesthetic education, because I believe that astronomy is a training ground of ecological thinking. The sensibilities astronomy cultivates can be hijacked to reinforce ecological sensibilities in dealing with our terrestrial affairs. So in the last instance, I argue for deep alliance between epistemic practices that are native to astronomy and to ecology. Because after all, there is no planetary without the extraplanetary, no environmental thinking without its cosmic context. Talking about races, whether infrastructural or no, there is one metaphor that immediately kind of jumps in my mind, and that's the metaphor of a smoking gun. In her classical paper, Historical Science, Experimental Science, and the Scientific Method from 2001, Carol Cleland, who's undoubtedly one of the legends of philosophy of science, argues against the persistent prejudice that the only true scientific method is a precisely controlled experiment. As this prejudice goes, sciences which are unlucky enough, quote unquote unlucky enough, to have zero to none chance of experimentally testing their hypotheses are somehow inferior. Amongst these unlucky sciences, Cleland finds many of those that are interested in phenomena too big in space or time to be meaningfully replicated under laboratory conditions. That means archaeology, paleontology, geology, as well as my favorite, astronomy. And many times, these sciences have to rely on historical hypotheses that postulate past causes of presently observable circumstances. So Cleland offers a list of some well-known examples: the hypothesis about the meteorite impact that caused the extinction of the dinosaurs, or the hypothesis about continental drift causing the spatial distribution of the Earth's landmass. But most importantly, Cleland introduces this concept of a smoking gun science, which she conceived to explain how historical sciences, such as geology or astronomy, actually work. According to her, their main research efforts are directed at searching for a smoking gun, a trace that sets apart one hypothesis as providing a better causal explanation for the observed traces than do the other. And this idea brings me to the largest possible landscape this presentation can potentially deal with, which is the universe per se. Perhaps if you believe in multiverse, it will be that. But for us that believe in one universe so far, this would be the largest landscape. And I'm sure some of you may be very familiar with this picture, because it is the cosmic background radiation or cosmic microwave background, also abbreviated as CMB. And it's a kind of omnipresent microwave radiation that is actually here kind of a smoking gun, a trace, an evidence of a past event hypothesized to be beginning of the universe, the Big Bang. This trace was always there, up there, all around us. But astronomy wasn't calibrated to notice it. First, it requires the right theoretical model of the universe that enables to formulate the Big Bang hypothesis. Second, it requires the right historical circumstances, in this case the advent of radio astronomy in 1930s. And third, it requires the right infrastructural setting. In this case, it is radio telescope, such as this horn antenna, which is located at Bell Labs in Holmdel, New Jersey, which, when I looked at the map, is only around 80 miles away from here. Some would add that there is also a fourth factor at play, and that's serendipity. Since cosmic microwave background was really discovered by Arno Penzias and Robert Wilson by sheer accident, and it basically presented in their observations as a kind of unexplainable noise coming from all directions that they didn't know how to actually get rid of. And so in this respect, CMB is quite a poetic astronomical proxy. It reminds me of a citation by the French priest and physicist Georges Lemaitre, as recollected by my good colleague from Antikythera program, Thomas Moynihan. The evolution of the universe can be compared to a display of fireworks that has just ended. Some few red wisps, ashes, and smoke. Standing on a well-chilled cinder, we see the slow fading of the suns and recall the vanished brilliance of the origins of the world. This poetic description, one that sees CMB as a smoking remnant of a festive gathering commonly known to cosmologists as singularity, brings me to the topic of light. Why? Because microwave radiation that CMB comprises of sits at the very end of the spectrum of possible wavelengths of light. And what I will do now is that I will move to the right, towards short wavelengths, the infrared and visible light. Now, a question. What is a night sky full of stars? Every night we look up at the stars, we see uncountably many lights, uncountably many messages from the distant past. The starlight we see have traveled thousands of years to reach our Earth, and it displays an archival image of the universe once upon a time, a natural photography of sorts. When I was talking about this research at Students' Roundtable at Goldsmiths more than a year ago, one of the suggestions I received from the crowd back then is to think about cosmic images as quote-unquote temporal montage. It also reminds me of Susan's yesterday comment on trans-temporal alliances and narrating scattered histories. And indeed, I think there is a lot to unpack in relation between traces and time. Traces, time. They are signposts of historical depth. More traces means more granularity, means more plastic historical picture unfolding in front of our eyes. And it also links to Lisa's talk that proxy landscapes are fabrications that fabricate. And they fabricate what? In this sense, they fabricate time. They fabricate time in which both truth and lie in the end appear. It is very likely that most of these stars that we see on the night sky harbor worlds, like those in our solar systems. Today, we know around 10,000 exoplanets in the universe, and most probably the number of actually existing exoplanets is certainly by several orders of magnitude larger. When we receive a beam of starlight from some distant solar system, a fraction of the starlight is actually reflected in our direction by the atmosphere of the exoplanet that transits in front of its host star. So the exoplanet's atmosphere functions here as a kind of mirror, reflector, remember? And for example, after the encounter with the water vapor in the atmosphere of the exoplanet, the light continues its journey through the universe uniquely modified. It contains an encoded message about the interaction with the molecule of water in the form of characteristic gaps or peaks in the spectrum of reflected light. So these gaps are called absorption lines and the peaks are so-called emission lines. And for example, on the right, you can see the absorption spectrum of Earth's atmosphere in mid-infrared, indicating clear signs of the presence of water, carbon dioxide, and ozone. And on the left illustration, you can nicely see the gaps and peaks in the absorption spectrum. Again, here we don't have a reflection, but we have a refraction here. The breaking down, also according to the Latin root of the word, the breaking down of the spectrum through the gaps. So this is another kind of cosmic proxy landscape here. We have an index, a stream of starlight, that tells us something about the landscape very, very far away, a landscape curved into a roughly spherical shape, commonly known as a planet. And to think about light as an indexical device motivates a speculation. Can we understand starlight as the ancestral first archive? An archive that stores information about the cosmic events spanning almost the entire history of the universe? And what if this act of appreciation of the archival affordances of starlight means to highlight, again, the indexical sensibility of astronomy, just as with CMB, of astronomy as a kind of historical science in search of Cleland's smoking guns? There is potentially even more to unpack here, actually, because light is a flow. It is a stream of particles rather than a singular object. So it is a very special kind of archive. It is some kind of like flowing metabolic archive. An archive as a process of continuous sampling. In this case, the sampling agent would be the star beaming the photons in the exoplanet's direction to sample the atmosphere. For this reason, exoplanet astronomy actually cultivates a capacity closely allied with the indexical sensibility, and that's a kind of metabolic sensibility, the ability to capture, decode, and utilize information in the metabolic flows. The indexical sensibility of astronomy also unfolds further in another cosmological domain, a domain that sits on the dark side of the universe, dark matter modeling. According to our best theoretical estimates, the visible matter we and everyone and everything we see around us is composed of presents only around 4.6% of the content of our universe. The largest portion of the universe is filled with dark matter. It's more than dark energy. It's more than 71%, and the remaining 24% is the dark matter that I'm going to talk about now. Still, there's a disproportion. Roughly like 4% of visible, or as it is called, baryonic matter, and almost 25% of matter is the so-called dark matter. So we do not know what this dark matter is composed of, but, and this is crucial, we can trace it by the movement and distribution of the structure of the visible matter. Since dark matter gravitationally influences visible galaxies and their satellites, and these basic cosmological structures of dark matter are called halos, with accompanying subhalos that mirror the clusterings of visible matter. So mapping and modeling dark matter means mapping and modeling the negative space of the universe. The relationship between the invisible and visible, between the image and negative space, is here quite analogous to that of the relationship between pattern and void in traditional Chinese carved seal. Emptiness is here the necessary precondition for the emergence of meaning. Hence, dark matter astronomy cultivates another kind of sensibility that is allied to indexicality, the sensibility towards the negative, the respect to the thing's right to opacity. To also gesture here at Edouard Glissant, because as Glissant puts it, agree not merely to the right to difference, but also, carrying this further, agree also to the right to opacity, that is not enclosure within an impenetrable autarky, but subsistence within an irreducible singularity. Opacities can coexist and converge, weaving fabrics, and to understand these truly, one must focus on the texture of the weave and not on the nature of its components. And I believe that we are in a very similar situation with the dark matter here. Another way how to spin this would be to say that there is a sensitivity towards computational abstractions as cognitive blisters that fill in the space of the imperceptible. For example, this lambda CDM model, which is kind of the standard model of cosmology. Models are tethered to the real by the indexical relations between visible and invisible matter observed in the universe. So index is in this sense something like an anchor of abstraction. And I want to double down on this point because computational abstraction brings the question of time into focus once again. In cosmology, computational models are basically time accelerators. They help us to compress temporal scales, and according to Carol Cleland, computation helps historical sciences to compensate for the inability to construct a controlled experiment, and hence to ultimately collapse the distinction between historical and experimental sciences. And now, I said previously that traces time, that they are signposts of historical depth. The historical depth correlates with the irreducible amount of events, of causal chains that need to unwind in order to arrive at the effect being observed, for example, the current distribution of dark matter. And these causal chains need irreducible amount of time to be computed and to be processed in the model. So in this sense, proxies trace the edges of the computational irreducibility, and the more proxies or traces model uses to anchor itself, the deeper is the model's historical fidelity. And that brings me to my conclusion. During my contribution, we have encountered three related arts of astronomical sensibility: indexical sensibility, metabolic sensitivity, and negative sensibility. So the idea, again, as I was talking about at the beginning, is about thinking about astronomy or hijacking astronomy as a kind of aesthetic educational tool, a kind of calibration of the senses, cultivation of aesthetic competencies that nurture philosophical intuitions. Because after all, optics was one of the favorite disciplines of early modern Western philosophers too. René Descartes or Thomas Hobbes wrote significant volumes on the issues of bending and reflecting and also refracting light. Baruch Spinoza was a lens grinder, and another philosopher, Leibniz, placed optical metaphors at the center of his metaphysics. Likewise, outer space research presents a kind of optical tool. It mirrors cultural imagination, analogies between the terrestrial and the extraterrestrial. And Lisa Messeridas talks about so-called gestures of cosmic relation, and this citation I tend to overuse almost in all my recent writing, since I really adore it. So thank you for putting it so concisely into these words, since it gestures at the ecological relevance of astronomy that I am so interested in tracing. And this relation of mirroring is an extremely potent motive to play with. But just as I mentioned at the beginning, astronomical sensibilities are both reflective and refractive. Hence, complementary to their reflective capacity, the astronomical sensibilities I have briefly reviewed today hide the promise of philosophical optics that are actually attuned to the exterior, to the outsideness that is spontaneously refracted towards us. And I believe that this is the deep point of the arts of astronomical sensibility, to cultivate the capacity of sensing the non-human mediations, all these smoking guns, all these remnants of the universal fireworks, luminescent archive index flows, and dark halos. But it does not end with sensing, and this is my very last point. Sensibilities unveil traces, traces unveil rules, and rules inform praxis. And at the beginning of this contribution, I said that astronomy is a training ground for ecological thinking, and that astronomy is a kind of aesthetic education. So the takeaway is this one. In the last instance, sensibilities to non-human mediation that astronomy cultivates are tools for reorienting and navigating action according to prompts the world confronts us with. Thank you.
Hey, so I don't have any sound, but just see if it'll work. I do not have sound. Can I just use the HDMI directly? Actually, you know, it's on the other side. So. Yeah. Just sound. Okay. Whoa, my head is spinning. Thank you so much for having me. Bobby, thank you so much for the invitation and for putting this on, and to the moderators for doing a great job so far, to the organizers for helping us keep this all moving. So I am going to present some work, and I just realized that I want to give a little bit of a preamble before I dive right in, just based on some of the things that I'm picking up from the presentation so far. So I just want to, first of all, sort of situate this talk in relation to some of my other research. So it's a little bit clear what I'm trying to do and really what I'm not trying to do also. So I'm a geographer. I was a landscape architect, kind of. I am a geographer principally of US militarism and empire. And I focus mostly on the Pacific and the Arctic. So in that sense, I'm about to bring things into a geographic space and like back down to earth in a very different way. But I'm also really interested in geography as a sort of imperial mode of spatial knowledge production, right? So in that sense, it's very self-reflexive. And I'm really interested in what I've been thinking about as these sort of geographic techniques of empire, which sort of puts together, you know, a grab bag of things from sort of science and technology studies, history of science, architecture, landscape, geography, etc. But I'm also really interested, just apropos the prompt that Bobby gave us about the sense of a sort of autographic landscape, to think about what geography and autography are when you sort of try to put them together. And in that respect, on the one hand, I'm really interested in this question of the graphic, right? This question of writing, of inscription, and the work that it takes to prepare a surface for inscription of some sort, right? And a lot of the presentations so far have sort of made that point, I think. I'm also really interested in this sense of geography as what my colleague Sharat Chari has called earth writing, and the sort of radical ways that that can open up geography beyond its sort of imperial provenance. Finally, I just want to say that I'm interested in this, in putting autography and geography together. What does it mean for the earth to be made to write itself, right? So how is the geo constituted here? In my own work in the Pacific and Arctic, this is sort of swerved through questions of the oceanic, the atmospheric, the electromagnetic, the orbital. So away from sort of terrestrial figurations of the Earth towards more fluid forms that really, for me, become a sort of constitutive problem of geography from the sort of late 19th century onwards. Okay, the last thing I want to say here is that this point about an inscription, I want to put another twist on it, which is to say, I'm interested in thinking about inscription as conscription, the way that things are made to be part of this apparatus of writing, right? And in that respect, like, that's the sort of geographer of empire part that I'm gonna sort of hit on pretty hard. Now, that all being said, I am going to shamelessly under-theorize everything else that comes after this, right? And I hope that's maybe a little bit of a breathing room, because there's going to be plenty of space to sort of pick up some of those threads. But let me just dive right in. So to test an island. This is Amchitka Island. It's in the middle of the Aleutian Island arc between the Alaskan mainland and the Kamchatka Peninsula. So over there, you see Kamchatka. Off the screen is the Alaska Peninsula, but this is sort of where we're situated. Just to give you a little bit of sense where we are, to look at it from both sides. It's important here because the Aleutian Arc is at the point of junction between the North Pacific Plate and the Bering Sea, right? So the North Pacific Plate sort of plunges under, subducted under the Arctic plate, and this creates a zone of intense tectonic and seismic activity. This little spot on the south of the island is the location of the Amchitka program. Has anybody ever heard of Amchitka or the Amchitka program? Yeah, neither had I. But suffice it to say that this is the site where 16% of the US nuclear tonnage was detonated. Right? Not the Nevada test site, not New Mexico, Amchitka. There are 3 tests, long shot. Sorry, these little bubbles are going to go away. I just want to make sure we really know where we are, because this geography was very unfamiliar for me initially. Long shot in 1965, which is 80 kilotons at almost 3/4 of a kilometer underground. Milrow in 1969, which is 1.2 megatons, even deeper. And finally, Cannakin in 1971, which was 5 megatons and almost 2 kilometers underground. Cannakin is the largest underground test that the US ever performed. Okay. And it looks like this. This absurd schematization of what it takes to build in this test into an island and to render this island into a sort of laboratorial landscape. Now, I want to go from this, and a lot of the images I'm going to show today are of these very sort of sober diagrammatic variety. The only one that's sort of spectacular nuclear violence is the next one. and its violence on the landscape, just to be clear, not particular bodies. Now, this is the Cannikin test. The Cannikin test is important because this is 1971. There were, at this point, huge environmental concerns about the effects of nuclear testing. So this is right after NEPA had been passed, requiring environmental impact statements. So Cannikin involved one of the first environmental impact statements ever created. There were all kinds of legal challenges. They went all the way to the Supreme Court, where they almost stopped it, like right up until the last moment. There was also a small organization out of Vancouver that had the harebrained idea of going to Amchitka on a boat. They called themselves the Don't Make a Wave Committee because there was big concerns about a tsunami that might be triggered. The boat didn't get there. It sank the first time. They got another boat. They tried to get out there again. By that point, they had renamed the boat the Greenpeace. This is where Greenpeace got started, right? So in many ways, Cannikin is both the sort of beginning and end of an environmental movement, right? Of this sort of imperial concrescence of the environment as something that needed to be produced in order to then be tested, and in that process, sort of destroyed. Okay, so what does that actually look like? How do you turn an island into a laboratory? For both Milrow and Cannikin, so Milrow was the calibration shot a few years before, the island was equipped with extensive in situ and remote instrumentation. So geotechnical preparation of the site was really complex. It involved boring several deep drill holes for geologic sampling, device location exploration, final emplacement. And just to give you a flavor of what this involved, I'm just going to share some highlights from a really sort of triumphalist report prepared by the Livermore National Labs, who oversaw the site engineering. 2 years of drilling and a record-breaking emplacement hole, 6,150 feet deep and 90 inches in diameter, with a 52-foot wide cavity mined at its bottom. Excavation generated a total of 3,300 in-place cubic yards of rock, 5,440 cubic yards broken, hoisted to the surface, a total of 2,070 rock bolts in lengths from 4 feet to 16 feet, 16,700 square feet of wire mesh, and 890 steel mats were used for ground support, after which a diagnostic canister, 264 feet long, and altogether 400 tons of cables and equipment were lowered downhole. I mean, it goes on and on and on like this, right? And in certain ways, this is telling a very familiar story about these nuclear test sites, right? This intense form of instrumentation, the sort of cabling of these spaces together. This was notable because it involved these, remember when, computers were rooms, we love to say oh, computers were rooms, and before computers were rooms, they were people. Okay, that's true, but these were computers in armored shock trailers. So that's what you saw in that video. So those were actually field deployed computers that were then recording the effects of the test in all kinds of different ways. Again, the Livermore folks are really fond of talking about this. This is an aerial shot, an infrared aerial shot of Ground Zero, just to give you a sense of sort of where it was. And these various sites were then connected to each other through these cable networks that allowed for additional processing facilities, recording, computation, et cetera. These were then articulated with things all over the island and off the island in the waters and geology around it. These were connected in turn to a broader set of cybernetic command and control sites from Livermore to Los Alamos to the White House. So again, this is sort of the familiar story, if you will, of nuclear testing, right? This kind of hardwired version of how to produce the environment as something that is able to record itself. Now, this is sort of layered over with all kinds of other, forms of older surveying techniques. So coastal surveys were done, of course. These surveys were extremely important because Amchitka is, as I showed before with respect to its sort of tectonic location, is a site of extraordinary biophysical productivity. Right, so you get these sort of deep North Pacific waters upwelling, hitting the Bering. It's basically where all of our cod come from and pollock. You know, did anybody watch The Deadliest Catch, that show? Okay, so like that, this is the zone we're talking about here. There are huge concerns about what kind of effects this would have on organisms around Amchitka and as a proxy for other islands in the chain, how that might affect more important sites of economic activity. Now, this kind of biophysical productivity had already been enshrined in law, right? So the Aleutian Islands Reservation was, again, one of the very first national reservations set aside for conservation purposes by Teddy Roosevelt. Now, there's something special about these reservations, because in this period, so this is, you know, early 1900s, this is 1913, these reservations were set aside as accepted from all civilian activity, but they still allowed for military use, right? The reason why they allowed for military use was because they were prospective coaling stations for the Navy to connect the dots across the Pacific because it was too far to get across at that point. Then this got sort of written into sort of post-World War I law around, okay, how can we figure out how to pre-position ourselves for some kind of Pacific dominance now that fuel oil is a mode of conveyance. This led to the sort of island hopping strategy of World War II and the setting aside of sites like Amchitka, which were built up as bases during World War II and then during the Cold War, as sites that could be brought into this sort of like military portfolio of activities while still being wildlife preserves, right? So when I say that Amchitka is representative of this sort of imperial mode of producing environment, you know, I'm not exaggerating here. Like this is sort of in one space, at least in the US case, where sort of environment sort of came together as an idea and where it was prosecuted through law. Now, if you look across the Pacific, by the way, if you're interested in this stuff, you look at Hawaii, Guam, Diego Garcia in the Indian Ocean. I mean, the co-location of military sites and wildlife reserves or protected areas is pretty striking, right? Now, because of these concerns, because of this sort of unique biophysical productivity, there was a whole battery of tests that were set up to assay the environment prior to Cannakin and also prior to the other tests. So you've got things like photogrammetry, freshwater studies, marine studies, terrestrial studies, avian studies. I'm going to come back to the sea otter surveys in a moment. It's very cute and it's like a really awful story. Just preparing you all. But I just want to read you this quote from what the editors of this compilation of the bioenvironmental survey, by the way, who mostly came from Battelle Labs in Columbus, what they say about this. Some will say it is a pity that it takes a nasty cause like weapons tests to produce the kind of detailed study that a place like Amchitka deserves. I mean, I could unpack that statement for the rest of the talk. We who have spent an important part of our lives there would rather be glad that a necessary evil can nevertheless produce information of lasting value to mankind. Okay, I mean, again, like I'm going to avoid the tendency to unpack this and theorize it, but just like linger on that question of value, information, the production of information, and this sort of generic category of mankind, right? Okay. Whole bunch of study sites across the island that ranged from using algae and other individual organisms as kind of biosensors, right? This goes back to the earlier idea, sort of sentinel species, right? As well as instrumenting these live boxes near shore and a bit offshore, where these different organisms that were in the boxes themselves could, in a certain sense, sort of compute the violence of the detonation to produce a particular kind of information about the bomb and its behavior in that media. It wasn't just individual bodies, it was about the relations between these bodies, right? So this is that sort of ecological question. Sort of how do these effects ramify, both with respect to specific relationships, trophic relationships, right? So like what happens if a certain species is more affected than others? What happens if you pull that out of the food chain? But also then, of course, how does radioactive material move through the food chain? These kind of questions that started with the Odoms in Bikini, for example. But what brings together all these different kinds of bodies, right? This is a very sort of pragmatic production of environment, right? There's no sort of romanticism here. What brings it all together is the waveform. How do you put together biological, hydrological, geological bodies? You pulse a wave through them. This is the sort of principle of semiosis. There's this weird paper that I found that was part of this set of studies where a geologist called this process geosemiosis, right? This attempt to sort of create a sort of chain reaction that would mirror a kind of nuclear detonation, but as a semiotic effect. Okay. Now, the first kind of way that I'm going to talk about here is this idea of the pressure wave. The blast produces a pressure wave out from the center of the island into the ocean around it, right? It momentarily, like you saw in that initial video, sort of literally liquefies the ground around it, right? It makes the rock molten, which then cools into glass, and that ripples outwards and becomes this sort of generalized liquid or fluidification of the environment. And this is how a signal passes from one space to the next, right? This is how the Earth becomes a kind of signal processing medium. This particular study, which was performed by our old environmental engineering friends Tetra Tech, used photogrammetric techniques to map that pressure wave by identifying superficial whitewater and then sort of extrapolating from that below the surface. Incidentally, these techniques were first pioneered for the Canadian grid method, which was part of the sort of colonial project of surveying Canada. So again, like these geotechnical ligatures between different modes of coloniality, whether they're nuclear or settler, I mean, not lost on us here, right? This goes back to this idea. There's this quote that is attributed to Roger Revelle, who's from Scripps, who ran some of the nuclear tests in the Pacific that are more well known. And he was said to have said that the bomb was a wonderful oceanographic tool, right? Insofar as it could produce these kind of sort of wave effects. There was an amateur radio man who went to Bikini who said something remarkably similar before Revelle. Just going to read out what he said. The measurement of wave motion is the first phase of the oceanographic program. In this respect, the atomic bomb is a wonderful oceanographic tool. Knowing the point of release of the bomb, its time and the amount of energy released, the oceanographers were able to make exact measurements of the height of waves, their action in shallow water, their effect on the sea bottom, and their eroding effect on the beaches in terms of both time and distance, right? So this becomes a kind of cartographic principle, an imperative, really, for what the bomb can do for the mapping of an environment, but also its sort of simultaneous production of an environment. Okay, gonna get to the otter part. Sorry. There's a long story about otters here that I can't touch on that has to do with the sort of colonial history of Amchitka and the Aleutian Islands with respect to US and Russian empires and its appropriation from the Unungan people, which persists to this day in sort of fishing quotas and all kinds of ways that, again, I apologize that I have to bracket that here. But the otters at Amchitka were relevant because they were one of the last remaining populations to survive from exploitation during the fur trade. So the US acquired Russia primarily because of otters and fur seals, not because of timber or fish or gold or anything like that. It was the fur fishery, right? That's why the Aleutian Island Reservation was set aside initially to sort of draw down overexploitation of the fur fishery. Now, this meant that otters were a protected species on the one hand, had been studied pretty well, and also they realized pretty decent approximation of human anatomy. Okay. So they did these photographic surveys to see where they were. during this incredibly named operation called Operation Warm Coat, where they took the otters from these various sites and relocated and actually seeded new populations in Washington and Oregon and California. So like that's where most otters on the West Coast come from now, is Amchitka. But the idea here was to catch enough, so they caught about 1,200 otters and started to figure out, okay, how could they become these sort of proxy bodies for registering the sort of pressure wave? There's one way. Take them to Columbus, put them in some tanks, test out these pressure levels and see what it does to internal organs and tissues. Then take them back, build these live pens 1 to 10 kilometers from surface ground zero. There were about 16 of these. And figure out, okay, what happens when you explode a bomb? How can it basically index the relation between the sort of interior milieu of organs and cavities, right? And the exterior milieu of the environment, these pressure waves. Incidentally, it may be that Kannakin was a joke about this because Kannakin means like a little drinking vessel. So if you read like Othello, there's a song that Iago sings about cannakins, and one of the scenes, anyways, cannakin, canister, all sort of same idea. One of the things that the contractors did was they drank and then resealed beer cans and affixed them to the pens, and if they were crushed, that was more than 10 psi. If it was less, then they wouldn't be crushed. But in fact, like the tank of the otter, like the otter body, was the cannakin that was being crushed here, right? And we see here, in a certain sense, much less of a kind of intense violence that we typically associate with, like the mushroom cloud, for example, and the lasting legacies of fallout in places like Hanford, for example, and nuclear radiation. We see instead a kind of grotesque intimacy of wave-based sensing here, to find and to exploit these sort of differences in pressure between different spaces. And through this, they basically reconstructed a kind of spot elevation of the pressure wave of the bomb itself. So with these otter bodies, then they were like, okay, this kind of damage, this sort of bleeding, this kind of rupture means this pressure was here relevant, and then sort of use that to forensically reconstruct this space. They insisted that only a couple otters died in this process, mostly due to handling stress. That was definitely not true. Part of the reason why they didn't find a lot of otter bodies was because what happened to the bodies themselves with respect to the effect of the pressure wave. So I'm just going to read this out. The missing otters were trapped underwater by cavitation from the blast. The animal had gained negative buoyancy because of the split-second vacuum created by the violent upheaval of the earth and ocean. Right, so this kind of like inversion of the wave to sort of make these bodies sort of sink and disappear, right? This sense of conscription that I was talking about, where the earth is sort of made to right itself through entraining these bodies in this kind of machinic apparatus, is simultaneously something that involves, on the one hand, acts of writing and acts of erasure, right? Superscription, overwriting, or exscription, writing out, right? These disappearances and erasures that have been referenced. Okay. I'm going to talk about one more kind of wave. This was Operation Longshot, 1965. This was a particular test because it wasn't about a weapon. It was about an island, right? So that's where the quote from the beginning of the talk comes from, to test an island. Operation Longshot was designed to, quote, determine the efficiency of explosive energy in coupling to the Earth. Now, this was part of something called Project Vela, which I'll talk about in just a moment. But it's important to remind you of the sort of context of this, like the geologic context of where Amchitka is. Supervolcanic region, lots of tectonic activity, like I said. This also means a lot of earthquakes. So this is part of the Ring of Fire. Now, if you look at where this is, see Kamchatka there to the left, you basically have the Ring of Fire divided geopolitically. So Amchitka becomes a great site to figure out what are the Soviets doing in similar spaces, right? Because these tests register as seismic events, right? The seismic waves that they produce were arguably the most important thing about this series of tests. Project Vela had 3 parts: Vela Uniform, which is the seismology part, Vela Sierra, which was the surface sensing part, and Vela Hotel, which was the satellite sensing part. Has anybody heard of the Vela incident? Yeah, okay. So if you're into conspiracy theory adjacent stuff, check that out. The Vela incident, because I'm not going to talk about it in this talk, but it's sort of too good to pass over, was a secret nuclear test that Israel and South Africa performed in the South Indian Ocean. They covered it up, even though it had been sensed by this system. So the sort of whole principle of having an effective way of sensing nuclear tests through this system was sort of proven correct, but then they couldn't acknowledge it because that would have meant like really bad geopolitics and basically calling out apartheid states, which, as we know, the US is not fond of doing. Okay, so this is going sort of from outer space, like deep into the another sort of unknown, right? The interior of the Earth. At this point, seismology was a little bit of a folk science, right? Instruments were not well calibrated across different contexts. If you look back at some of the stuff that would be in the sort of domain of what Lukáš was exploring, the kind of imagistic representations of what's going on in the interior Earth are like equally fantastical as some of those sort of angelic images. So figuring out sort of how to use the bomb as a seismological and seismographic tool was equally as important as this sort of oceanographic question. And this birthed this field, Susan, this is for you, of forensic seismology. So this is 1973. This is coming out of the Vela program, which was funded by the precursor of DARPA, which is just ARPA, and was really very clear about, okay, this is not pure science. This is science with a purpose. This is science that needs to be sort of politically tractable, that can stand up as evidence in international court. That follows on from the Geneva negotiations about the test ban treaty, right? So there was a very clear-eyed sense of this. Now, what does this actually look like? Well, it turns out that if you map these spectral signatures of earthquakes versus nuclear detonations, they look a little bit different. The problem is, when you're in a space like this is Amchitka, with all the seismic activity overlaid on the left, or on left, yep, left. Okay. So picking out a seismic signal in that context was extremely difficult, which meant that not only did you need to instrument the whole region around it, and not only did you need to instrument sort of a broader area to the point of becoming a kind of almost a hemispheric project. This needed to be a sort of bureaucratic program of global scientific production, right? So now we have something called the Worldwide Standard Seismograph Network, right? Another part of the Vela conspiracy stuff, which I won't go into too much. But needless to say, this came out of the Vela program, where in allied territories across the world, they sort of set up these sensing sites in order to figure out, okay, how can we triangulate, and I mean triangulate very literally, and I'll show you in a moment what that means, these signals across these different territories to account for the movement of these waves through different kinds of geologic and oceanic media, right? Because the Earth is not a homogeneous medium. This looks like some weird sacred geometry shit. It's not. This is just the experimental arrays that they were trying to use to figure out what the optimum configuration for a seismographic network would be, and then how to set those up in a kind of fractal pattern, right, or a recursive pattern across sites that were well selected and these broader geographies. Now, one of the things that this does is produces an immense increase in data. So as this project keeps going, it produces so much data that in something kind of like a sort of Paul Edwards style story about data and climate science during the Cold War, there's a sort of reorganization of the state form around computation, around environmental computation. You get these really fantastic graphics like this. Seismology enters the computer age. This is from some of the internal publications. And the computerized environment. Oh, sorry. Bobby, do you want to take a picture? Wait, sorry. Okay, wait, I'm going back. There we go. Yeah. And this is sort of what this ends up looking like, to set the Earth up to kind of right itself, right? To conscript this whole set of bodies into this machinic arrangement in order to both produce this sort of inscriptive surface, right, the environment, but then also to become this kind of self-writing machine. Canakin ends up producing the most data ever recorded about an earthquake because of the sensor network that was set up around this. That ranges from these particle diagrams, these incredibly fine-grained sensors that are sort of tracing how a particle moves at these different stations, to these refigurations of the entire Earth as a kind of fluidic medium that's processing these signals. And in this respect, we see sort of all the world becoming a wave. I have some more, but I'm going to stop there.
Thank you so much for agreeing to be our moderator.
Can I speak? Okay, yeah, no, I was like trying to figure out. Well, I guess while we're setting up, I just thank you to Bobby for the opportunity. Thank you to the department and to our speakers. It was really wonderful to hear your all's talks. Really kind of thinking through different ways of understanding, relating, and like teasing out the world by using traces kind of as a proxy for understanding it, and like all the way from space down very deep underneath the ground. And I guess kind of one of the first questions I wanted to pose to you all, and something I was thinking about through many of your all's talks, was just the act of translation, and kind of what that means to you all in each of your all's work, because I think it can be something that's often flattening when it comes to information and data, but also can really like bring out the ability for large audiences to relate to it, and create a lot more meaningful interaction with that.
Wait, can I ask a clarifying question?
Yeah.
Do you mean translation with respect to like sort of conceptual operations of translation, or translating like the sort of technical work to sort of, I don't know, figure out more of its sort of general meaning?
I guess kind of, I mean it in both senses of it. I mean it in like the literal translation of like the physical trace of something, but also like thinking about it in terms of translation from medium to medium.
Yeah.
I have a couple of scattered thoughts on translation. I guess like the way how I would approach the question would be probably through the way how translation occurs between the trace and the model to which the trace is somehow the interface or sort of the anchor. So for example, when we have a trace such as the movement of the galaxy, we can actually infer or translate it into this negative space of like the dark matter distribution. And so in this sense, the translation here would be again some like accompanying gesture that comes together with the anchoring of the index to the model. But I guess like what is really important in translation is the problem of compression and information loss. And the translation in this sense needs some like compensating mechanism that doesn't just reduces the complexity of what is translated, but allows for unpacking of what is compressed. So when you have a zip file and then you kind of like unpack it back, I'm not sure that it is just translation that does this, and I'm not sure that translation in itself is sufficient to kind of like do this operation. So to me, from the philosophical perspective, I sense here a problem with compression, and I sense here a problem that perhaps is on designers or people that do visualization to sort of like cope with to create an actionable strategies to prevent information loss. Yeah.
Maybe related to that, for me, I don't really think of the process, all the different steps, all the transformations that are necessary to kind of, produce traces or make them legible as acts of translation. For me, translation implies that there's a certain missingness that has to be filled in, that cannot really be automatized. And like, very often when we talk about, visualizing climate change or things like that, that becomes also a problem where you have a distance between, what we think of the phenomenon and whatever representations we use, that is a distance of time, a distance of scale, and of everything, where you need these kind of maneuvers to deal with this missingness. But I don't think, I found it really fascinating, the kind of how both of you approach this from opposite ends in a way, even though you had very, talked about similar infrastructures, because like Lukáš talked about sensibilities and how you these kind of bodily modes of sensing, well you talked about the kind of this military apparatus there where everything is like completely automated and like made scripted. So I think this kind of question of translation is a little bit in between somewhere.
I'm just going to add one last thing there. I think I'm inclined to think about translation more from almost a sort of literary perspective on this, and especially about a sort of poetic approach to translation, which sort of takes that sort of incommensurability as an opportunity to do something different. And I guess in the spaces that sort of my really, honestly horrific story covers, there's so many more spaces for sort of opening up these alternative things that island means, that history can reveal, that sort of different things that the Earth can be, that I've, of course, sort of glossed over here, but that I think that in many ways, sort of in the sense of like translation as a sort of geometric turn, right? As sort of rotation of some sort. It's like it allows for another move. And that sort of semiotic swerve can help sort of in various cases sort of break that what feels like this incredibly conscriptive and constricting chain, this sort of geosemiotic chain that projects like Vela and the MCHITKA program were intent on constructing.
I'm actually reminded of Adam Bobet's Pulse of the Earth here, where we see also a certain kind of translation between the Java's geography and kind of like let's say the abstraction of the Anthropocene or the abstraction of the geological timescales. And I feel like there is an important, perhaps like a side note on local knowledge as something that is the accompanying anchor of the index in this sense. And this is something that should be somehow preserved in this in the translation towards the other kinds of models, whether it's computational or no. Yeah.
I think one of the other things I've been thinking about too is like traces that are intentionally resistant to kind of our ways of sensing them, or like I think you could think about it from both perspectives too, of like traces that are resistant to like the state's way of knowing and meaning, and like traces that the state is resistant to letting us as a public know. And I was just kind of wondering your all's thoughts on the way that gets represented in the world.
One of the interesting things about the MCHITKA program was that it was highly publicized. So even though many of the materials that I ended up sort of working with were from formerly classified documents, a lot of the stuff that I started with was it's just out there as a matter of the public record.
Is that where the term became for the basic from? Because that was a shop, it wasn't actually from the island, it was directed to the shop, you see this one, two babies.
Yeah, right. I mean, that's a good question. I don't know. Yeah, that's right. I mean, there's this sense of like, I mean, again, the Vela, Project Vela was explicitly a peaceful project, right? It was to further international peace and the enforcement of the test ban treaty. So it was in their interest to publicize that sort of work with that mission attached to it, but then also to sort of make this data, these data available in a way that, as one of the seismologists who was involved at the project says, like, gave him a career. It was like, I was just doing this work and then suddenly I had like big DoD bucks. And suddenly seismology is a big science in the Cold War sense.
Interesting here, if we're going to stick with this moment, which is that we gave to your question, it's kind of spot on about like traces that they want us to see, but they don't mean the thing that we that they
Exactly.
say. And so they often would take things, put it out through scientific literature, and assign it a purpose that was completely different than what they were learning from the test that they were doing. This happened a lot in ecology, that a lot of the studies that we're doing using satellite-based remote sensing to study crops, like this is in the interest of caloric abundance. They're actually using them to study biological weapons for targeting crops, but they would circulate it quite widely and publicize it so that things were just kind of hiding in plain sight. And I think similar to your project, I guess this thing, it's like they're not hiding the trace, they're amplifying the trace.
Yeah.
But what it means is something totally different for them.
Yeah, I mean, there is this saying that the most important trace is the missing trace. And so, I mean, this kind of, again, this kind of unobtrusive methods idea that, you have this kind of charismatic traces that are, grabbing your attention, but you may have this kind of experience of causality, but like it may, may be an illusion, and like to be wary of that, and the traces that are not there are the ones to think about. And then for me this is kind of interesting to think about data not as a form of bureaucratic evidence that in reality basically just often gives you the justification to do what you wanted to do anyway, but as this kind of speculative moment where you have something and you think like what could be connected to that, and like what is the larger context, and the meaning is in the context, not in the trace itself.
I like this idea of the charismatic trace because it also reminds me of this relation between trace and history, in the sense that when I said that trace is time, the trace is basically, the more trace, if I think about it kind of in this naive way, the more there is traces, the more history in a certain way. And so then the control over who traces, who creates traces, who produces, fabricates traces, and interprets traces is then also like control over history and control over archive, of course.
I just want to add on to that last point, because it reminds me, with respect to your point about sort of thinking with astronomy, I mean, thinking with geophysics and geology as a question of semiotics. So C.S. Peirce, whose sort of semiotic theory is the basis of a lot of sort of contemporary thinking around this stuff. He was effectively unemployed for most of his life and picked up work for the Coast Survey, which was run by his dad. So in the same way that you're talking about these sort of philosophers sort of forming their ideas through lens grinding,
yes.
Optics, right? I mean, this is very much where Peirce's semiosis comes from, is thinking about sort of the Earth as a kind of as a signifying surface, but also something that sort of triggers this, what he called infinite semiosis, right? This like unending process of just like this pouring out and sort of interconnecting of signs. And I think that sort of the capacity to then sort of reconstruct sort of history of the Earth through potentially more or less charismatic traces ends up becoming entirely sort of that situated history of semiotics.
That was a long time in my book project material witness talking about the Earth Ray and the geophotographic convergence. I guess I'm drawn more to thinking about paradigms of sensing and registering rather than writing and inscription. And yes, I'd like to hear your thoughts on the why stick with the sort of the graphe, like why that's actually still kind of useful, especially when we think about computational images that are much more fields of navigation than images to be read. And so the navigational in some way has now superseded you don't read images, you navigate, or data is navigated. It's not something you actually read. Well, there's machine reading, of course, I understand, but I was just curious about like whether sensing might actually open things up differently in the projects versus a semiotic kind of framework.
Yeah, I mean, I've been struggling with this a lot, and this was also the reason why I moved away from the kind of idea of indexical visualization. And but obviously, it's still relevant somewhere in culture. So for me, it's kind of an oscillation between sensing as a kind of a bodily technique or like a sensibility of like Lorraine Daston is like amazing in this regard when she talks about like how the chemist trains their nose and things like that, and the question of meaning with the kind of semiosis, and then just the kind of the question of like, okay, intensities and transformations and energy that are kind of not necessarily making any prescriptions of meaning, but are kind of a little bit like moving away from this kind of mind-centric framework of semiotics. Now, of course, there are different ways to also read Peircean semiotics. I mean, John Durham Peters, like read it in a very non-human centric way. So obviously it's a very elastic framework because it's so old and you can kind of read it in many different ways. But yeah, I mean, for me, it's really kind of constantly moving around between these different poles. And I completely agree with you that the sensing is really a very key part of that.
Yeah, sorry, I didn't formally open it to questions, but please feel free to ask questions.
Hi, thanks for all of those. So I was really struck how waves were in all these talks, sound waves, seismic waves, and of course, all of the the wavelength and everything. And also the ripple, right? When you had the ripple, that was kind of a metaphor, it then of course came back in a huge way in your talk. And so I was also thinking across all these about the relationship between proxy and proximal, right? Whereas proxy is often premised on a distance, and proximal is about overcoming that distance, right? Being next to and near. And that made me think of, is the wave something that like begins as a proxy or a trace, but then actually leads to the possibility of being proximal between two distant things. So I just kind of wanted to launch that and hear, for those of you thinking more about waves, where that might take you.
I love that thought, but I'm having really, do I really have to go first? Yeah. Well, I guess.
For outer space, right? We always imagine that we don't touch, but of course we always are.
Yes. Yes. Yeah. Yeah.
Actually, do make it proximal.
Yeah. I kind of. It's the collapse between the proxy and the proximal in the sense really that the wave becomes the. I always have this image in my mind from the Close Encounters of the Third Kind, where there is this alien with this super long finger that is kind of like prolonging. And so to me, the wave is this super long finger in a certain sense. It is like this. There's a moment of intimacy suddenly there, like through the way how the basically the atmosphere of the distant exoplanet indirectly touches us through the wave of the light that is modified by the encounter between the original source, between the light wave from the original source, which is the distant sun, and then it kind of like comes like uniquely modified in our direction. So to me, I really sense here like that the distance is kind of more like in the end in the eye of the beholder, in this sense that the distance after all is the secondary category here, and that the proximity comes with the proxy in this sense always, perhaps also referring to yesterday's Susan's talk again when she was talking about the entanglement as a certain conceptual tool, and also like an actual physical hypothesis that helps us to bridge the distances.
There's something kind of funny here. I'm thinking about Jeff Snyder, theorizing photography, and it jumps on that like whole hammering about indexicality. And it's like, just to be clear, photographs don't index objects; they index photons. And I feel like that's precisely what we're saying here. It breaks that correspondence to the thing that the photon bounced off. And it's actually the photons are what talks about. The surface that's recording and sensing photons. Incidentally, we as meaning-making entities have to be patterns on them that we associate with something. But the actual act at a material level is just a register of a type of chemistry or a type of electrons interacting with the photon.
Which I feel bad because you had your hand up before me. Yeah.
So I think my question, I'm kind of thinking back a little bit to Lukáš when you mentioned compression, and I don't know if it's too off base to ask what might be a little bit of like almost a methodological question. And when you said compression, I was then thinking about like latency, which is like embedded in the way you're showing us these images and this idea of looking at a montage through time. And I'm just kind of curious for all of the panelists, I think it kind of appears in different ways in a sense, right? So Alexander, for you, it's through the wave, or like latency is like information in a sense, but also just from like a historiographic perspective, right? Like I couldn't help but see just like unclassified, 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 right? Sort of appearing on all of the evidence, but it's sort of presented in a way that was so clearly, but in kind of a seamless way in a sense. So I don't have a good sense of kind of just like the appearance of that information and sort of the delay and withholding of that. And I think Dietmar, with you just describing maybe in a more embodied sense of like descending the glacier and it was hot and seeing these pictures, or sorry, the sort of markers in a sense, and sort of recounting that back to us here. So I'm wondering if either both is kind of like a methodological question, or even just the question around sort of traces and data that we've been talking about. If any of you might comment on this idea of like latency, perhaps as it relates to compression, as Lukasz raised.
To me, this compression is definitely linked to opacity in one important sense, or like to certain like imperceptibility or invisibility. Like I use this term like in the lecture, like of the cognitive blister, or something kind of like a surrogate in this sense, like for some lack of understanding. And when I was also referring to the Glissant quote, I think the nice part in that quote is really about him talking about actually following the lines of those weaves of the invisible object rather than understanding the essence of that object. Yeah, so you kind of like focus on the gestalt, on the silhouette in this sense. And I guess like compression is basically in this sense, or the method or the problem of compression here is kind of like linked to like what's actually hidden inside that black box, or kind of like what fills the space inside that silhouette. And to me, then, like the opacity is important here from the perspective of thinking about actually compression as, in this sense, the temporary sort of like a proxy itself. Like the model that is a compression becomes the proxy in this sense for something that may be unpacked, not necessarily unpacked, and maybe actually an ethical choice of an observer whether they want to unpack or no, whether they actually want to get rid of the compression. In this sense, the compression itself may be actually maintaining compression, may be a gesture of a certain kind of like respectful distance or a respectful withdrawal to the object of the study. Yeah.
I mean, I think in my case too, and I'm just trying to link this back to some of the spirit of the other questions that have been asked also. I mean, latency itself is a kind of information, right? Because it tells you something about the medium that the wave moved through, and how long it took, and why it took that long, and why it sort of deflected in certain ways, and what the sort of shape of the wave looks like is itself sort of measuring of latency. And so in that respect, you know, to pick up on something that Lukasz was talking about earlier about this sort of the making of time, right? It's also like latency, I think, focuses or refocuses us on the question of timing, right? There's a timing that matters here, not just because it's a question of measurement, but because it's a question of strategy. So with respect to that sort of series of unclassified or declassified documents, you know, at the same time, right, as I was mentioning earlier, there's a whole flood of public data being produced that is linked with a narrative about futurity and what we can do with these data that will help us understand the Earth better and maybe control earthquakes. And then we can do, you know, there's the famous Project Plowshare stuff, which is all about, you know, creating an isthmus across, or, you know, artificial isthmus across Panama, and, you know, an Arctic seaport and through nuclear excavation, like all that stuff, which never came to pass. So in that sense, you know, I'm interested in that question of latency, as it then gets us to the question of compression, which is to say, like, if we take information, latency is a kind of information, and information, just to sort of use the Bateson version of that, like a difference that makes a difference, then compression is like the sort of preservation of that difference and the shedding of the forms of difference that we don't care about, right? And that itself is a way of making sure that the sign can like carry on, that the index can can like fulfill its function, which is to point somewhere. And not point back to something, but to point to the next thing that it's supposed to do, which is to say, like, set in motion a kind of strategic series of operations that is all about timing.
Since it's so late, I'm just going to make it a comment instead of pretending, because it probably was a comment anyways. I love this notion of the grotesque intimacy and those images that you said, like no one was harmed because no one was there. I sort of see them. No, I know it's in a quote. It's in a quote, but I sort of see them as like an Arthur Jaffa kind of montage. This grotesque intimacy. It's sort of like this sort of visualization of 5 centuries of kind of pain and violence, and in that way this kind of image of endarkment, and I guess I wonder what I was going to pretend was a question is like, is the human non-human distinction actually doing the work that you want it to do here? Because it seems that part of what is opening up, especially as far as this kind of history of visualization and philosophy, is like a different kind of secular observation or something, like so much of that work was also against Islam, for example. Like so much of the kind of history of like Western scientific thought is actually, producing a non-Islamic deity. So I wonder about sort of displacing the human and opening up to other, sort of figures, because that binary human, non-human doesn't seem to be, it seems to be like too clear almost for the work that you're doing. That was the question.
I like that as a closing comment. Great, thank you so much. That was a fantastic conversation. Thank you for sharing your work, and Gabe, thank you for moderating.
Thank you.